I'm Joe Graydon.
And I'm Terry Graydon. Welcome to this podcast of the People's Pharmacy.
You can find previous podcasts and more information on a range of health topics at peoplespharmacy.com. Is it possible to reset our biological clock? Our guest today says aging is far more reversible than we thought. This is the People's Pharmacy with Terry and Joe Graydon.
Dr. David Sinclair told the New York Times that cells can clean themselves up. They can get rid of old proteins. They can rejuvenate if you turn on the youthful genes through this reset process.
What does Dr. Sinclair do to maximize his chances for a long and healthy life?
We'll also learn how experiences early in life shape the epigenome and alter our biological clock.
Coming up on the People's Pharmacy, we'll try to find out how we can reverse the aging process.
In the People's Pharmacy Health Headlines, COVID-19 infections appear to shrink certain areas of the brain. Researchers in England utilized brain scan data already in the UK Biobank. Nearly 400 COVID-19 survivors were invited to undergo a second brain scan after they recovered. The investigators also scanned a comparable group who had not been infected. Survivors showed a marked reduction in gray matter in the parts of the brain that process the senses of smell and taste. In addition, the virus also impacted areas of the brain that are important for memory. According to the authors, the loss of gray matter in memory-related regions of the brain may in turn increase the risk of these patients of developing dementia in the longer term.
There's growing concern about the rapid spread of the Delta variant of SARS-CoV-2. 2 weeks ago, it accounted for 6% of U.S. COVID cases. Last week, it had risen to 10%. Now, public health authorities estimate that the Delta variant accounts for 20% of U.S. cases. That's a dramatic increase in a short time. As a result, Johns Hopkins modeling suggests that there could be a new surge of infection in the fall unless many more Americans get vaccinated. There's also the possibility that some future variant will be able to escape the protective power of the vaccines. That's why news from the University of North Carolina at Chapel Hill is welcome. Researchers have created a vaccine that can protect from several different types of coronaviruses. So far, the scientists have only tested this shot in mice, but the hybrid vaccine works surprisingly well. One of the lead investigators, Dr. Ralph Barrick, noted the vaccine has the potential to prevent outbreaks when used as a new variant is detected. Because it may also protect against other coronaviruses, it could help prevent the next pandemic.
High blood pressure is a risk factor for dementia as people age. However, people who take blood pressure medicines that cross the blood-brain barrier might be protected from this hazard. An analysis of 14 randomized controlled trials with 12,900 volunteers compared people on the ACE blood pressure pills captopril, fosinapril, lisinopril, perindopril, and ramipril to those on other medications that don't get into the brain. In cognitive tests, people on these ACE drugs had less drop in their scores on memory tests from year to year. In addition to the ACE inhibitor medicines, ARBs, telmisartan and candesartan crossed the barrier and were associated with a slower decline in memory performance. The big question is whether these drugs can help prevent dementia, and no one has a clear answer to that yet.
Are statins associated with cognitive impairment or Alzheimer's disease? This question has been controversial for decades. A new study in the Journal of the American College of Cardiology adds more fuel to the fire. The Esprit trial stands for aspirin in reducing events in the elderly. Over 19,000 older people with no pre-existing cardiovascular disease or dementia participated in this trial between 2010 and 2014. About a third of the participants had been taking statins when the aspirin study began. All of them took tests to measure cognitive function at the beginning of the study and a few years later. The current study analyzed the results to determine whether statin use was associated with cognitive decline. Although the investigators concluded that there was no link between statin use and dementia, their results are not entirely clear. People who were on statins at the start of the study were about 33% more likely to be diagnosed with probable Alzheimer's disease. The accompanying editorial is titled, "Statins and Your Memory. Forget about it." It concludes that statins in older patients are unlikely to have a major impact on cognition. And that's the health news from the People's Pharmacy this week. Welcome to the People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. Legends about a fountain of youth stretch back thousands of years. People around the world have been looking for ways to delay or reverse the aging process for a long time. The mythical fountain has never been discovered, but scientists are now uncovering ways to push the reset button on the aging process.
If we can unlock the secrets of biological aging, we may be able to slow the development of many chronic diseases that afflict older people. That could change the way we think about preventing conditions such as heart disease, diabetes, and macular degeneration.
Later in the show, we'll talk with Dr. Terry Moffat of Duke University. She'll describe how early life experience shapes gene expression. Surprisingly, young children with limited self-control grow up to be adults who age more rapidly. What's going on? Will the stress of the pandemic have lasting biological consequences?
But first, we turn to Dr. David Sinclair. He is a professor in the Department of Genetics at Harvard Medical School and co-director of the Paul F. Glenn Center for the Biological Mechanisms of Aging. He is also co-founder and co-chief editor of the journal Aging. Dr. Sinclair's latest book is Lifespan: Why We Age and Why We Don't Have to.
Welcome back to the People's Pharmacy, Dr. David Sinclair.
Thanks, Terry. It's good to be back on.
Dr. Sinclair, you were quoted in the New York Times as saying, "Aging is far more reversible than we thought. Cells can clean themselves up. They can get rid of old proteins. They can rejuvenate. If you turn on the youthful genes through this reset process, you might get some benefits." So what are you talking about when it comes to a reset process?
Well, my little lab was just experimenting to try to reset the clock in cells and in the eye, and we were able to do that. And that's why I think aging is going to be easier to treat and potentially reverse than cancer. And what I'm talking about is that what we've discovered over the last year or so in my lab, and a few others around the world, is that there is a reset button in the body. We typically take old mice and we reverse their age. We were able to restore the eyesight of old mice. And now my colleagues and I are ticking off the various tissues and organs to reset those, to restore them as though they were young again.
Well, speaking of mice, Dr. Sinclair, and it seems to me that there is research that gets published like almost every other day these days when it comes to longevity research. But the research article that I'm looking at says that Israeli scientists extend lives of mice by 23%, say may be possible for humans. And this was making headlines just this week. That doesn't come as a particular surprise to you, I suspect. They're talking about something called SIRT6 protein.
That's true. It did not come as a surprise because the scientist who ran the study is a former trainee of mine, and he's working on a gene that we've been working on since he was with me in the early 2000s. And this SIRT6 is one of 7 genes in the body that we've shown protect the body against diseases of old age and aging itself, and that he was able to turn that gene on at higher levels in his mice, and they lived that much longer, and they lived longer because those mice were healthier. They didn't get cancer and heart disease and dementia like a normal mouse would.
Well, we're definitely interested in something that could help people not get heart disease or dementia or cancer. Is there the likelihood that we'll be able to translate this research from mice into humans?
Well, that's always the question. If you look at where I've come from in my research, we discovered these SIRT genes, SIRT6, in yeast cells, just simple baker's yeast. And so we've come 99.9% of the way towards humans. And if this principle doesn't apply to us, it would be really surprising to me. Now, I've co-founded a company to activate this SIRT6 genetic defense pathway. And so we're many years already into the process of what I hope will one day be medicines to slow down and even reverse the aging process in the way that I described.
Now, I found it interesting in the popular press in interpreting this Israeli researchers' data. They're saying, well, that could equal 120 years for humans. Is that really within the realm of possibility?
Well, it's already been achieved by at least one person that we know of, Jeanne Calment from France. She died 1997, I recall. But so it's doable. It's just not that frequent. And so what we're talking about is giving the average person the chance of getting up into their century and beyond. And it's, to me, it doesn't even seem that crazy to get us there. It turns out if you just do the 5 main things that doctors tell us every week to do, exercise, eat the right things, don't eat as often, don't get obese, don't smoke, and make sure you have good mental health and sleep, that on average gets you another 14 years of healthy life. So that's it, just the start. If you apply some of these technologies and medicine, some of which are already on the market for other diseases like diabetes, I don't see why we couldn't push the average age of humans up at least 5 or 10 years beyond what we have now within our lifetimes.
Well, Dr. Sinclair, we started this interview talking about a reset button. And are you suggesting to us that following the simple lifestyle recommendations that you've just rattled off is in some way a reset button?
Well, we don't know if doing those things, such as skipping meals or eating the right foods, actually reverses aging. I think that it's unlikely that you'd have a big impact. But what we do know that's really important is that we can now measure aging. In my lab, if I just took some of your spit or your blood, I could tell you in a couple of days exactly, within a few percent error, how old you are, not by birthday candles or how many times the earth has gone around the sun, but biologically, how old you really are inside. And it also is very informative. Most people who look young are young internally as well. The reason I bring that up is that I foresee one day where we will have our age measured, and we will have recommendations by either companies, consumer companies, of course, assisted and in adjunct to doctors. But that would be a future where I could see that we could, at a minimum, slow down aging by doing those right things, but then using the new technologies that we've just discovered in my lab to literally reverse the age of the body. And the way we did it in mice, they went back about 50% in age. So that we're talking about a potentially dramatic change in the future.
Now, Dr. Sinclair, when we talked to you last, you said that when you were 48 years old, you took a 5-factor longevity blood test that showed your biological age was actually 58. You were 10 years older than your chronological age, biologically speaking. And I'm just curious, what kind of test did you take, and what did you do to change that?
There's a company that I consult for called Inside Tracker, and they do a blood test that you can get from your home. Someone comes there. That's what I did. Or you can go to a local clinic. And they measure a bunch of things. And they give you what's called an inner age number. What I did to reverse that number, just within a matter of months, was to start skipping meals. So these days I skip mostly breakfast and lunch. So I lost a bit of weight, which was good. I also started taking 2 supplements, one called NMN, and the other one called metformin, which is a drug actually that is prescribed for type 2 diabetes, high blood sugar. And together, those 3 things brought my blood biomarkers and my inner age calculation down to 34.1.
Dr. Sinclair, that is really quite impressive that you were able to change that figure so dramatically within several months. What is NMN?
Well, I'll tell you what it isn't. It's not M&Ms. They probably won't make you live longer.
Probably not.
NMN stands for nicotinamide mononucleotide. It's a relative of the molecule niacin, or vitamin B3. And the body uses it to make another molecule called NAD. Why is NAD really important? Well, we lose it as we get older. We have less and less, about half the levels at age 50 compared to 20. And these SIRT genes, such as SIRT6 that we talked about earlier, require this NAD molecule to work. So the problem is, as we get older, we think is that these defenses, these sirtuin defenses against aging, decline. And the prediction is that if we take NMN, it will boost those defenses back up to how they were when we're young.
You are listening to Dr. David Sinclair, professor in the Department of Genetics at Harvard Medical School. He's co-director of the Paul F. Glenn Center for the Biological Mechanisms of Aging. Dr. Sinclair is co-founder and co-chief editor of the journal Aging. He's co-founded a number of biotechnology companies, including Certis, Ovascience, ArcBio, and Life Biosciences, among others. Dr. Sinclair's most recent book is Lifespan, Why We Age and Why We Don't Have to.
After the break, we'll find out about a simple way to slow down the biological clock: skipping meals.
Does it matter which meals you skip?
Some people take the diabetes drug metformin, even though they don't have diabetes. What's it doing for them?
Dr. Sinclair describes the Yamanaka factors and why they're so important when we want to delay or even reverse aging.
Isn't it time to change our way of thinking about disease from treating it to preventing it?
We'll also get Dr. Sinclair's insights on epigenetics.
How can we push the reset button epigenetically?
You're listening to The People's Pharmacy with Joe and Terry Graydon. The People's Pharmacy podcast is supported in part by CocoVia Memory Plus. CocoVia cocoflavanols support both cardiovascular health and cognitive function by promoting healthy blood flow, transporting oxygen and nutrients to vital organs and muscles, including your heart and brain.
CocoVia Memory Plus has 750 milligrams of cocoflavanols, the plant-based nutrients from fresh cocoa that have been proven to help boost memory.
CocoVia Memory Plus is backed by 4 clinical trials that demonstrate improvement in 3 different aspects of memory: long-term memory, spatial memory, and word recall. The studies show improved brain function in just 8 weeks.
You can try the benefits of CocoVia Memory Plus with a 25% discount off your first month. Use the code PEOPLES25. To get the full benefits, take it daily for 8 weeks. Cocovia is offering People's Pharmacy podcast listeners a 10% discount on subscriptions. That code is PEOPLES10. Learn more at cocovia.com.
Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon.
The People's Pharmacy is brought to you in part by Kaya Biotics, organic probiotic products made in Germany. KAYA Biotics.com.
Also by Cocovia Memory Plus, a cocoflavanol supplement backed by 4 clinical studies that show significant improvement in 3 different aspects of memory. More information at cocovia.com.
Today, we're talking about research into the aging process.
Our guest is Dr. David Sinclair, professor in the Department of Genetics at Harvard Medical School. He's co-director of the Paul F. Glenn Center for the Biological Mechanisms of Aging. His latest book is Lifespan: Why We Age and Why We Don't Have to.
Dr. Sinclair, you have mentioned a few times now skipping meals as a way for us to at least slow down our biological clock somewhat. Tell us about the magic of skipping meals. What's going on?
I think they call this intermittent fasting.
That's right. We used to call it caloric restriction, which was just eating small meals. But now we found through many studies in animals and in people that the best bang for the buck is to have some hunger during the day. And so some people just skip breakfast. Other people, like myself, skip breakfast and lunch as best we can, and then just have a healthy dinner. And that gives you about 18 hours at least of a period of fasting. And what we know from many studies is that that period of fasting has many health benefits. For a start, it turns on your cell defenses, these sirtuin genes that I've studied and I talked about. They get turned on by being hungry. But the good news is you don't have to feel hungry. You just have to skip the meal. In fact, I've been doing this now since February, and I don't feel hungry. I just drink some water or I have a cup of tea, and I fly through to dinner, and then I really enjoy dinner. So I really have not only do I feel better, but I expect that I'll be healthier as I get older.
Does it make any difference if you skip breakfast and lunch and have dinner, or have breakfast and lunch and skip dinner?
You can skip breakfast or dinner, but do one of those two because you want to extend the period of fasting during sleep. But some people need breakfast. I don't. But if you do need breakfast, then try to skip dinner.
I'd also like to ask about metformin. It's such a fascinating drug. French lilac is kind of the origin of metformin. It's been used for decades. It was used originally to treat diabetes, I suspect, before people even knew what diabetes was. Tell us a little bit more about why you're taking metformin even though you don't have diabetes.
Well, because I believe in preventing diseases before you actually get them. And I had an argument with my doctor recently about this. He said, well, you don't have a family history and you don't have symptoms of diabetes or prostate cancer. And I said, why would I want to wait till I get those diseases before you treat me? Because it's often too late. Metformin is a drug that is given to people who have high blood sugar, but it's also been shown that those people live longer and are healthier than people who don't even have type 2 diabetes when they take this drug. And studies of tens of thousands of people have confirmed that metformin protects you against a variety of other diseases, from cancer to heart disease and even frailty. And we're actually conducting a long-term trial of metformin in hundreds of people as we speak to confirm these predictions.
Now, you said cancer. And in particular, you mentioned prostate cancer. Is there data to suggest that metformin can reduce a man's risk of developing prostate cancer, or perhaps once he's been diagnosed and treated, of a recurrence? And are there any other cancers that metformin may protect against?
Yes, in fact, prostate cancer is one of the types of cancer that metformin has been shown to be protective against, and also to delay the progression of those tumors. And there are many others as well. So it's a really interesting drug, not just for diabetes, but for other age-related diseases.
Dr. Sinclair, we understand that your laboratory has studied something called Yamanaka factors, and that this may actually be very important as we look at the prospects of delaying or reversing aging. Can you tell us what are Yamanaka factors and why are they important?
Yamanaka factors are actually genes that get turned on early in our life when we're fertilized and start developing into an embryo. And they initiate a program that keeps the cells very young. And what we've shown is that if you turn on 3 of those genes at the same time in adult tissues, for example, a mouse's retina and optic nerves, it can reset the age of an old eye to make it young again, and the mouse gets its vision back. And there are other researchers around the world that are showing that you can reset the age of other organs in animals. And the hope is that these 3 Yamanaka factors and perhaps other genes and even a pill one day could be taken to truly reset the age of the body so that we can fight diseases. And if you reset the age of the brain or the liver or even the skin, we actually think that you will reverse these diseases that plague us when we get old.
Well, I think that point is the critical issue that a lot of people are considering as they're getting older. They basically say, well, I don't want to live to 120 if my brain isn't working, or if my kidneys are failing, or if, other things are just not working the way they're supposed to. Why prolong the agony? It's not so much how long you live, but the quality of your life. How do you respond to people who say, well, why do longevity research if you're just going to have a terrible old age?
Well, that's because people don't understand what we're talking about. We're talking about, and we actually have the ability to slow down aging. So we're not extending the frail part of life. We're talking about extending youthfulness. So don't imagine being 90 or 100 being frail and in a wheelchair. Imagine being that age and still playing tennis and hanging out with the great grandkids, even starting a new career. That's the kind of life we're talking about. It's really no different than other types of medical research. We all want to be healthier and help people not to get sick. It's just that this research has the potential of not just preventing and slowing one disease, but perhaps all major diseases that happen as we get older.
Now, what about your colleagues? I mean, there are a lot of researchers out there who are doing the kind of work that you have been in the trenches with for quite a long time, and yet mainstream medicine does not yet seem to have recognized, acknowledged, and supported this kind of work. What I mean is the pharmaceutical industry is thrilled with the idea of a pill for every ill. Let's wait till you get diabetes and then we've got a medication. All you have to do is watch commercials on television to see the diabetes drugs and the cancer drugs and the blood pressure drugs and the heart failure drugs. So we'll wait till you get sick and then we'll treat you. How do you begin to change that way of thinking?
Well, the medical establishment does take a while to retrain, but it is happening that more and more young doctors are excited about this research and even looking at using current medicines to slow down aging in some of their patients. But it's a small group, it's a minority. So how would we change their opinion? Well, one way is to train the new doctors, and I give lectures both at Harvard and around the country on this topic. And I wrote a book that now many hundreds of thousands of people have read, including many doctors, and that's helped change people's opinion as well. And also, I think more scientists should speak to the public, like I'm doing today, because there's really exciting research going on, and revolutions in medicine are already here and just around the corner as well.
Can you tell us what research you're most excited about, please?
Well, without a doubt, the reprogramming work, the ability to turn back the clock in the body, is a breakthrough that I didn't even expect to happen in my lifetime. I didn't know that the body had a reset switch. And now we're growing little mini human brains that we can give Alzheimer's disease to, and we're aging them rapidly. We now have control over the aging process, both in the forwards and reverse direction. And we're learning how to treat these mini organs and make them younger again. And those little organs will serve and are serving as models for future studies in people. And I'm hoping that the first patient we reverse aging in will be in the next couple of years. We plan on treating eye diseases, blindness, and restoring their vision like we did in mice recently.
Perhaps you can share your insights on something that our listeners are beginning to pay attention to, and that's called epigenetics. For far too long, I think people have just assumed that their genes were kind of written in stone. And your work is suggesting that written in sand might be a better analogy, and that epigenetics can make a huge difference in how those genes are expressed.
Well, 80% of our health in the future is due to this epigenetics. What that means is that there are control systems that turn on and off our DNA, our genetics, which we, of course, get from our parents. But the epigenetics is malleable. Epigenetics, these control systems of our cells, change when we don't eat. They change when we eat the right things. They change when we sleep well. And that's 80% of our future health. And that epigenetics is actually what I believe controls the aging process. And it's what we read to determine how old somebody is. And when we reverse the aging process, it's that epigenetic clock that gets reversed. And we think that that ability to now read the genes as though the cells were young again is what makes the tissues healthy and why those mice could see again.
There's a study just out of Italy. The scientists took blood samples from 81 people and they conducted whole genome sequencing to look for differences between the centenarians and the younger people. And what they found was that people who live past 100 in Italy tend to have a unique genetic background that makes their bodies very efficient at repairing DNA. What are your thoughts about this brand new research from Italy?
The Italian study is really interesting, and it fits with what we've found in our lab. We've discovered that DNA damage, and actually specifically the cell's requirement to go and fix that DNA damage, is what drives the epigenetic clock, the aging process forward. The way to think of it is similar to a DVD or a compact disc. When we're young, we can read the information, or when the compact disc is straight out of the pack, we can read it. But as we get older, we get more scratches on that disc, and you cannot read the music or the genes correctly. And so this epigenetic change, these scratches, we found are largely due to DNA damage. And the way that works really is the damage distracts the cell and makes proteins go to where they shouldn't, and then they don't get reset to where they started. And over time, we get those scratches and the cells forget that they're young and how to function properly.
And how do we reset that CD?
We use the Yamanaka genes, 3 of them that come on when we're young as embryos. And when we turn on those young genes, those proteins that became distracted by the DNA damage somehow find their way back to where they belong on the DNA when we were young. Now, we don't know exactly how that happens. How is it that a protein knows where to go back to where it was 30 years ago? All we know is that it's possible because we can do it. We do it every day in my lab. And now we're looking for what it is that signals. What is it that tells a protein where to go back to? And when we find that, I think that's going to be another major breakthrough in aging research. So, we do want to understand what that mechanism is. And I hope that one day, maybe just in 5 or 10 years, we'll have this same ability to reverse aging, but with a pill. And imagine that right now we use gene therapy, which is complex, but it could be very simple one day.
That does sound exciting.
There's a lot of talk around stem cell therapy and a lot of skepticism. Any thoughts about stem cell transplants?
Stem cells are very important, there's no doubt. The problem with stem cell transplants is, unlike our method, which restores the existing cells that are in place, putting stem cells into the body, often they don't find their place. If you inject stem cells into the eye, for example, where we can reverse blindness, the cells struggle to integrate into the complexity of a tissue. They might go there and stay there for a few months, but eventually they don't last. So that's the trick, is to either get the stem cells to go where they should, or what I prefer is to just reset the existing cells and make them young again, and they don't need to find their way because they're already there.
Dr. Sinclair, is there any way for us to test our epigenetic age and tell how old we are biologically?
Yes, in fact, there are a few startup companies that are offering this service, either through spit or blood or for just a mouth swab. The problem right now is it costs a few $100s, but we've just had a breakthrough in my lab that'll bring the cost of that down so that everybody can afford it. And that way people can know how they're doing on life's trajectory and make adjustments. And we'll provide recommendations as well in hopefully a company that will be launched pretty soon. My goal is that everyone will be able to not just figure out what they think will work, but actually determine what will work. The way we have a dashboard on our car, we'll have soon a dashboard on our bodies as well.
In summing up your hope for the future, do you imagine that you are going to be able to change how people live and how long they live in your lifetime as a researcher?
Well, I think just through my book and the number of people who have changed their lifestyle, I suspect that I've already changed a lot of people's lives for the better. But in terms of medicine and technology, yeah, I'm hopeful that I'll have at least one successful drug. I've got currently a number of irons in the fire there. But I'm also helping other researchers and people who have technology such as biomonitors. In fact, I'm sitting here with a biomonitor stuck to my chest here. It's a little patch that has a battery and a Bluetooth, and it's measuring my body at 1,000 times a second. And it will alert my doctor if I have a pending heart attack or I get pneumonia, or even if I'm not sleeping correctly. That's the future of healthcare. And I would predict that within 10 years, there won't be a person in a nursing home that isn't wearing something like this.
Dr. David Sinclair, thank you so very much for talking with us on the People's Pharmacy today.
Oh, thanks, Terry. Thanks, Joe, for having me on again.
You've been listening to Dr. David Sinclair, professor in the Department of Genetics at Harvard Medical School. He's co-director of the Paul F. Glenn Center for the Biological Mechanisms of Aging. Dr. Sinclair is co-founder and co-chief editor of the journal Aging. His most recent book is Lifespan: Why We Age and Why We Don't Have to.
In the brain tissue experiments that Dr. Sinclair described, the researchers culture tiny organoids from brain stem cells. They can test how brain tissue reacts to various treatments.
After the break, we'll talk with Dr. Terry Moffat about how early life experience affects gene expression.
What factors are most important for epigenetics and aging?
How does self-control affect how fast we age?
Do emotional states like anxiety or depression change the speed of aging? Will the pandemic have a lasting impact? If so, can we reverse it?
You're listening to The People's Pharmacy with Joe and Terry Graydon.
The People's Pharmacy podcast is sponsored in part by Kaya Biotics. Kaya Biotics offers the first probiotics which are both certified organic and hypoallergenic.
All probiotics are produced in Germany under laboratory conditions with high-quality ingredients and under strict regulatory oversight.
The 3 available formulas are created for very specific purposes, such as strengthening the immune system, fighting yeast infections, and helping with weight loss.
To learn more about Kaya Biotics probiotics and the important topic of gut health, you can visit their website, KayaBiotics.com. That's Kaya Biotics.com. Use the discount code PEOPLE for $10 off your first purchase. Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon.
The People's Pharmacy is brought to you in part by Cocoa Via Memory Plus, a supplement with 750 milligrams of cocoa flavanols, the plant-based nutrients from fresh cocoa that help support memory. More information at cocovia.com.
And by Kaya Biotics, organic probiotic products made in Germany. KAYABiotics.com.
How do our choices and our behaviors affect our genes? What does self-control have to do with aging? How can we enhance our epigenetics by the way we deal with psychological challenges?
To answer these questions, we're talking with Dr. Terry Moffat. She's the Nan Cohen University Professor of Psychology at Duke University and Professor of Social Development at King's College London. Her expertise is in the areas of clinical mental health research, neuropsychology, and genomics. She studies how mental and behavioral disorders affect the biological processes of aging. Dr. Moffat is co-author of the book, The Origins of You.
Welcome to the People's Pharmacy, Dr. Terry Moffat.
I'm grateful for this opportunity to be here.
Well, thank you for joining us. Dr. Moffat, when we think about longevity, we often focus on genetics. Did Grandma live into her 80s or 90s? Is Dad doing well at 86? But what about epigenetics? Our listeners are familiar with the term, but how does life experience impact gene expression?
Epigenetics is the study of how methylation markers change on top of the genome. And this means that genes can be scheduled or turned off or on by these markers. Methylation isn't the only method, but it's the best one for researchers to study. And we know from studies of animals that changes in the diet of a mother rat can change the epigenetic markers of the rats, the small rats, later on, and it can change the color of their fur and their behavior and things like that. So that's how the field got started.
Well, it seems to me that another thing we always think about when we think about longevity is older people, wrinkles, gray hair. There's nothing wrong with wrinkles and gray hair, but we don't tend to think about the other end of the age spectrum. How did these people get to have wrinkles and gray hair? Where did they start? And can you tell us, please, about early life experience and your interest in how that affects longevity?
Thanks. The research that we do is following a group of people who were all born in 1972. There are 1,000 of them, all the babies born in one city. And they're now entering their 50s. And we have tracked their physiology and their health and mental health all their lives, repeatedly assessing them. And so we're able now, using the research data that were collected in the 1970s and 1980s, to go back and look at what factors from their childhood are influencing how fast they're aging today.
What factors have you found to be most relevant?
It's interesting. Some of the most relevant ones might surprise you. So, for example, cognitive learning abilities. Problems with cognitive learning are evident by as early as age 3 or age 5. And people who were not learning efficiently as very young children, we found to be aging really fast in their late 40s and early 50s. And we also found that they were poorly prepared for old age. They're financially on track to be poor as old people. They're physically on track to be sick as old people. And they're already socially on track to be lonely and lacking a network of social support. So we found that cognitive learning was a really important factor. Another factor was self-control. It's a personality style. It's evident as early as age 3 or age 5. We measured it in 3-year-olds and 5-year-olds. And really, 5 decades later, we have the children who had poor self-control, according to their parents, their teachers, and our research observers, now as they enter their 50s are aging really fast. Their faces are rated as looking 4 years older than the faces of their peers. And they're also poorly prepared. Again, poorly prepared financially, poorly prepared socially with a social network, and poorly prepared physically to avoid illness in late life.
What do you think is going on?
Well, there could be many explanations for these personal characteristics such as self-control and cognitive learning affecting the pace of aging. One is that people with poor self-control and people who don't learn efficiently just seem to be less aware of health behaviors. So they don't monitor their own sleep. They don't avoid addiction to substances. They aren't aware of the need to stay physically active. They eat a poor diet. So their behaviors don't really prioritize preparation for healthy aging. So that's one story. A different story might just be that people who don't learn efficiently or who have poor self-control don't end up sticking with education for very long. So they end up with a less amount of education than other peers born the same year. And they end up, as a result, getting lower paying jobs. And those jobs that are low paying tend to be stressful. They tend to be dangerous. They tend to expose them to conditions that harm their health. And so it could be that there's, a pathway through education and through the workplace that leads to fast aging in midlife.
Dr. Muffet, I'm fascinated by the self-control issue. It kind of reminds me of a famous experiment that I am sure you are familiar with involving marshmallows.
Right.
And I've often wondered, what is it about the kids who could delay their gratification by just staring at that marshmallow and not eating it when the investigator walks out of the room? And I think that's also true of other people as well. It's like, why do some people say, well, I can delay my gratification for a day, a week, a month, maybe even longer? And other people, I want it now.
Right. We invested quite a bit in measuring young children's self-control when these 1,000 people were children in the 1970s and 1980s. So we had repeated measures of their ability to delay gratification, to take turn on the playground with the playground equipment, to respond properly in the classroom when they were in primary school. So we have lots of measures of their self-control. And what we have found is that getting prepared for a healthy late life is all about delay of gratification. It's all about planning ahead. It's all about being able to anticipate what your older years will be like and plan accordingly and make decisions today that will end up maximizing your health, your social networks, and your financial security in late life. It's all about planning ahead. And that's why the marshmallow test is so important as an aspect of preparation for aging. Most people think, when you study aging, the studies tend to start with people who are in their 60s and then go forward from there and study the part of life where people are declining. In contrast, what we've done is we've started with birth and followed people forward to ask how they're preparing, how their whole lives prepare them for a healthy late life.
Now, what about emotional state? What about people who are chronically anxious? What about people who are worriers? What about depression? What about other psychological challenges?
I think if there's one thing that a person can do to improve their late life, It's to make sure that their mental health is attended to when they are an adolescent or a young adult. So we know that mental health problems like depression, anxiety disorders, ADHD, bipolar disorders, even substance abuse, all of these peak during late adolescence and young adulthood. So really the 20s are when most people experience mental health problems. And in our research, we have found that people who had mental health problems, when followed up into their 50s, tend to be aging extremely fast. They already are showing memory problems. They walk very slowly. They have poor balance, like an older person who's much older. Their MRI brain scans showed a thinner cortex already in their late 40s and early 50s. And we don't usually see that in people who are under 60 years old. They also had hearing problems and vision problems. So it looks as though early mental health problems are a canary in the coal mine. They let us know that there's something wrong in our brains, in our minds, in our bodies that is going to start emerging as fast aging when we reach our 50s. And that means that if we can treat early mental health problems and take good care of our mental health, that might really pay off.
I am thinking about the year we have all just been through. Very high stress, very high anxiety, high schoolers who couldn't go to high school, didn't have proms, didn't have graduations, didn't have all kinds of things, didn't have an opportunity to connect with friends face to face. Will there be fallout from this pandemic in 20 or 30 years for these youngsters?
I think I agree with you. I mean, looking at my my staff, my students here at Duke University, people have been under an enormous amount of stress, and we see a lot of depression and anxiety and attention deficit problems and a lot of heavy substance abuse, all of these things exacerbated by the pandemic. What we might see then in about 4 decades is a sort of a little mini epidemic of fast, accelerated aging in people who lived through the pandemic. This is called a cohort effect in social science, and we know that there are cohort effects from other kinds of historical events that have happened. For example, people who have lived through wars, or people who have even lived through a very positive time of life that affects everyone. The baby boomers are a great example. That's a big cohort effect where we know that the population was affected by an event, which was World War II. So it's possible this really could happen. I'm really working with young people now to try to get them to really attend to their mental health problems, because often people think, oh, they grow out of it, they're young, they're healthy, no problem, don't worry, everyone gets depressed. And all of that is true, but our research is showing that it can come back to bite you decades later in terms of late life diseases. So one study we did used the entire population of New Zealand and looked at their electronic medical records. And we found that the people who had an electronic medical record for a mental health problem in early life, when we tracked them for 30 or 40 years, tended to have elevated rates of COPD, macular degeneration, cancer, heart disease, diabetes, glaucoma, Parkinson's, Alzheimer's, dementia. These things were all more common in late life if a person had been suffering from depression, anxiety, bipolar disorder, or ADHD early in life. They're separated by over 30 years of time in the electronic medical records. So it's really quite amazing that we can see that pattern, but it's definitely there for a whole country.
Dr. Moffat, that's pretty scary. And I'm wondering how our listeners can make changes that will allow them to age more healthfully, especially after a year of this social isolation and anxiety. Can they and their children and their grandchildren reverse the age-accelerating impact of COVID-19?
Well, I think the thing that people can do most is just be aware that there are connections from early life experiences to later life pace of aging. And that way, that kind of awareness changes how people make decisions about how to live. For example, we have tracked these 1,000 people as they've been growing up from childhood to their late 40s, early 50s, and detected many things that happened in their early lives, their mental health, their self-control, their cognitive abilities that are now influencing how fast they're aging. But you know what? They're only in their late 40s. It's a great time to turn things around. So by changing behaviors, by getting proper medical attention as soon as possible, by watching your sleep, your diet, your exercise, there's plenty of time to improve your preparation for aging. Plenty of time.
And I'm assuming psychotherapy can also make a difference.
I think it probably could, although I have to say this hasn't been tested systematically. So, just as with any kind of treatment approach, we want to have a clinical trial that's done properly in order to document that the effects are reliable before people try it. I think psychotherapy will probably be a great way to help, but I can't point to a test quite yet that shows that it slows aging.
Well, this is an ideal time for that kind of research.
Dr. Terry Moffat, thank you so much for talking with us on the People's Pharmacy today.
It was a great experience. Thanks.
You've been listening to Dr. Terry Moffat. She's the Nan Cohen University Professor of Psychology at Duke University and also Professor of Social Development at King's College London. Dr. Moffat's research is in the area of genomics and neuropsychology. She studies the consequences of behavioral disorders on the process of aging and is a co-author of the book, The Origins of You. Our first guest was Harvard professor David Sinclair. His latest book is Lifespan.
Lynn Siegel produced today's show. Al Wodarski engineered. Dave Graydon edits our interviews. B.J. Liederman composed our theme music.
The People's Pharmacy is a co-production of North Carolina Public Radio, WUNC, with the People's Pharmacy.
The People's Pharmacy is brought to you in part by Kaya Biotics, organic probiotic products made in Germany. KAYA Biotics.com.
And by CocoVia Memory Plus, a cocoa flavanol supplement backed by 4 clinical studies that show significant improvement in 3 different aspects of memory. More information at cocovia.com.
Also by Verazana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Now with an annual health club plan. Online at verazana.com.
Today's show is number 1263. You can find the podcast on our website, peoplespharmacy.com. You'll also find an additional interview with Aaron Sharoni, who studied under Dr. Sinclair. It's an extra podcast.
When you go to peoplespharmacy.com, you can share your thoughts about today's show in the comments section of show number 1263.
You can subscribe to our podcast through your favorite podcast provider. We post the show on our website on Monday morning. You might want to share it with a friend or family member.
At our website, you can sign up for our free online newsletter to get the latest news about COVID-19 and other important health stories. By subscribing to our newsletter, you'll also have regular access to our weekly podcast and find out ahead of time which topics we'll be covering. In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thank you for listening. Please join us again next week. Thank you for listening to the People's Pharmacy Podcast. It's an honor and a pleasure to bring you our award-winning program week in and week out. But producing and distributing this show as a free podcast takes time and costs money.
If you like what we do and you'd like to help us continue to produce high-quality, independent healthcare journalism, please consider chipping in.
All you have to do is go to peoplespharmacy.com/donate.
Whether it's just one time or a monthly donation, you can be part of the team that makes this show possible. Thank you for your continued loyalty and support. We couldn't make our show without you.